Hello, my name is Petra Hunger. I am an SD and LE consultant since 1998 and was certified in TM90 in 2013. The enhancement guide written by Holger Polch has helped me a lot to get started with the TM development. I thought I'd make it available to all of us. A film is easier to digest than a book, and I've added some system demos where possible and necessary. Special thanks to Avato Systems to let me use their SAP system to make the films during my holidays. The target of this document is to describe the possibilities and use technologies to enhance SAP transportation management. It does not intend to provide a complete and detailed description of all enhancements. Instead, it describes the usage of the available enhancement technologies based on some basic examples. The current film looks at the first 14 pages of the enhancement guide, explaining business objects, associations, actions, determinations, and validations. And the next film, part 2, looks at consumer implementation basics. And the third film looks at creating field extensions, subnodes, and everything that is described in chapter 3.3. So let's get started with the business object processing framework. Business objects are the basis of the TM application. Each business object represents a type of uniquely identifiable business entities, described by a structural model and internal process model, as well as one or more service interfaces. Examples for business objects in TM are the forwarding order, TRQ object, or the freight order, TOR object. The object can be accessed via transaction /BOBF /conf_UI. In the system demo, you will see how the object is made of nodes and subnodes and how you can open each one of them and look at the detail. Here you can see, for example, the root node, which is the header of the forwarding order, TRQ, and you can see the item node. So here you can see as well nodes that you find back in the structure of the forwarding order, which you can see here. For example, here you have the stages node, stages writer, and there's a node which corresponds to this stage. And then you have the charges writer, and you have a node called transportation charges. So let's come to the elements now of the BOPF model, Business Object Processing Framework. And the most important element, of course, is the node. A node is a semantically related set of attributes of a business object. Nodes can be used to define and structure your business object. The attributes of a business object are defined by data dictionary data types. Nodes can be hierarchically defined and related. So you can see here, for example, the root node, it's the header of the forwarding order, and the item node, it's below the root, and then you can see the item can be further subdivided, and the nodes are structured in a hierarchy way, so that you can see what belongs to what and what is the actual hierarchical structure. Each business object has only one root node. Nodes are defined via compositions in a tree, but nodes can also be related in an arbitrary structure via associations that can be separated from the tree structure. Business object representative nodes are placeholders for other business objects and their association to these. They are only for visualization of their association to other business objects. So, nodes, set of attributes semantically related to a business object, yes, and the business object here is the forwarding order, TRQ object. The attributes are defined by data dictionary types, and we will see that there's really a linkage to the data dictionary. Each business object has only one root node. Okay, so one forwarding order has only one header, and one freight order has only one header. Okay, after this theoretical explanation of the node itself and how it's linked to the root node and to about the business object in general, let's look at the details per business process object. And so in this picture you can see what you can see on the right side when you double click on a node, and basically we will see what elements are used to link the business object to the data dictionary objects. So of course you have the name and the description and then the node type. and what kind of category it is. In this case, we have the root. It's the root node, which is data of the. I think it's the it's a TOR. It's a freight order. So now let's look at the data module that's behind the node. So first of all, you have a combined structure store root underscore k. It has the field list, and this guy here is showing is representing the field list belonging to a certain object. But it also has the key. You can see here the key. So we have the data structure of a node, and we have the node instance key. We have also the key of the direct parent, and we have the key of the related BO instance. So in this case, it's the root key. In addition, we have a the same combined structure. We have it as a structure, and we have it also as a table. And in addition, we have a data structure, and this data structure has a field list only. So you can see here there are no keys. And then again, we have the distinction, or I haven't explained it, it comes later in the film. We have a distinction actually between persistent data and transient data. So in the data structure that doesn't have a TR in brackets, you have the persistent data, meaning the data that is kept forever, whereas the data structure TR has the transience attributes only. So this running man is actually symbolizing that in the data structure that's transient, we have only data that is used at runtime and it doesn't need to be stored anywhere. So that's actually cleaning up a little bit the data structure, so you have a smaller field list in the data structure because you have only the persistent data. Then you have the extension include, and here you have the symbol new, which is which actually symbolizes that you can add customs fields at this place. So instead of adding custom fields as an append in VBAK, like you might know it in SD, where you can just append the table, you have a separate extension include, where these additional fields can be added and can be viewed at once. Last but not least, you have the database table that is storing the persistent data, and here you have the symbol for storing data. So this is very important to understand those details of the business process object, because you need them for data declaration, and whenever you use the business process object, you want to select data from it, you want to modify it or retrieve it. So it's really important to remember well the structure. So I think we should better add to the theory. We should have a look at this in the system. So we go into the business object browser using BOPF/conf_UI. We can look at the business object list. We have only 19 business objects. It's not a lot in the whole of TM. And then, of course, at the end, we find the TOR object for the freight order and the TRQ object for the forwarding order. When we double-click on the object, we can see the node structure, so the root and the item can be opened, what I explained earlier. And then we also have the node elements, but we come to that later. So let's look at the root node, and let's look at the different elements that I explained just now. So here we can see the combined structure, and when we double-click on it, we can see the key, the parent key, and the root key. And we can also see the different fields that are available in the forwarding order, like the forwarding order number, TRQ ID, what else is interesting, the order date, consignee ID, etc. So this is very familiar to anyone coming from the classical ABAP. It's a data dictionary. So then the same thing we have as a table. Of course, now we don't have the field list again, it's just the table. And so it's referring to the structure as well. But we can directly declare this when we declare a table. And we have a data structure, so this is the same thing as before, but we don't have any keys. So now here it starts directly with a TRQ ID and no parent keys, or root keys, or key, or object keys. Then we have here the extension include. Okay, let's have a look at the extension include here. And this is the place where we can add custom fields. So we can also double click, and we can see here we have already some fields starting with /ASTM, our custom area, which were added to the forwarding order item. And then last but not least, we can see a database table that's used to store the objects. It all looks the same, except that we have here a database key, which is node ID, the OB key, and then the rest of the fields are the same. To finish this part on the node and the BOPF framework properly, let's look at the different type of objects that you can find in the BOPF browser. And so we have seen the business process objects, the TOR and the TRQ objects for the forwarding and freight order, or freight and forwarding order. And now let's look at the other type of objects. You can have dependent objects. So you can see here in the picture one person depends on the other, and that's the same way with the dependent objects. For example, an object transportation charges cannot exist without the related order, the related freight order or forwarding order. So dependent object can only exist in the context of another object. Then you have master data objects. These objects are created by the user in the SAP ERP system, for example, the customers, and then they are transferred to TM via the CIF interface, or you can create them directly in TM. For example, examples of master data objects are locations, business partners, and materials. And then the third type we are going to look at is actually called metadata objects, and here you can find the customizing objects like the freight unit building rule or the planning profile. So this was just a small summary of the kind of objects that you can find in the browser. And now let's move on with a BOPF design, with two of the most important BOPF design principles. BOPF design principles. BOPF controls the application business logic as well as the data retrieval of the buffer and persistency layer. The main design principles are a clear separation of the business logic and the buffering of data. So you can see here the business logic on one side and the data buffering on the other side. It's really separate. And a clear structuring of the business logic into small parts with a clear separation of changing and checking business logic. In the old world, user exits were provided and the user could write checks, determine data, and throw out messages within the same program. The BOPF model foresees one element for each of those contents. This allows a clean structure of source code. This is especially interesting when several developers are coding, but it's good in general. It also allows that source code can be reused, and you have a better overview what's actually happening in your source code. And also you can configure the point in time when the coding is called, rather than each programmer is developing his own coding to say if it's in create or change mode. The next element that we are going to talk about is the association. An association, and you can see here the association in the system. An association is really a direct, unidirectional binary link between two business objects. In this case here you have a source node attachment folder where you can store the attachments in the document, and the associated node is the root, the header, and you can see here the cardinality 1-to-1. So it's a direct unidirectional binary relationship between two business objects, It can be used to navigate from one node to the other. Unidirectional means really only in one direction. So source node is the attachment folder, and associated node is the root. There can be nodes within business objects or between different business objects. And when it's between different business objects, for example, between the forwarding order and the freight order, it's called a cross-business object association. There can be parameters to filter the result, so you can look at only certain parts of the associated node. And the association can only be defined between two nodes and in one direction, which I said already repeatedly. Nodes can be compared to the joins. The idea is comparable, not exactly the same thing. Joins in the old world can join two tables within the sales order framework, header and item tables, for example, or two tables outside of the sales order framework, sales order and delivery table. But it's not exactly the same because the cardinality is not defined, and also it's not within one direction, and you can even combine 3 or 4 different tables in a join, what you cannot do in a business object join. So let's look into the system and let's look into the BOP framework. Transaction code is /BOBF/conf_UI. So we are looking at the business object, and in this case at the TOR object, the freight order. And in the TOR object I will double click. We look at a node structure where we have the root and the attachment folder, but the association is in the node element part. So here we can see the attachment folder again and an association. So you can open the association and have a look. Here we have 2 different associations. One is from the source node attachment folder to the associated node root, from the bottom to the top, let's say. And we can see here the association name, it's to root, makes sense. The type is association to root node, and you could have different ones. So for example, this one to parent will have the category to parent node. Then we have the cardinality, as I was explaining, it could be 1 to 1 or 1 to n. We have source and target node, or source and associated node, and the resolving node type. So this is a very classical node. We don't have a class and we don't have parameters. So let's look at another node and another association of a node where we have more interesting things. For example, let's take item TR. There we have a number of associations. And then look at child item. And here we can see we have a different association category, reverse foreign key association, cardinality 1 to n, and we have source and target node, or source and associated node the same, and another resolving node. And here we have an association class. We can double click, and this class method creates an instance of the target node, or resolves an association. So for the time being, that's it, what we want to show about the associations. Of course, you can browse in the system anytime for yourself, create your own associations or use the existing ones. The next element that we are going to look at is the action. An action is an operation performed on that node. It's like some type of coding, like for example add the container, or what you can see here, add the package, add the product, add the package item. This is actions. They can be used to allow the external triggering of business logic. So for example, some action from outside can trigger the action. To trigger an action, you must specify the key for the instances on which it must be performed and any input parameter that it requires. An action can only be performed with a number of instances defined in the cardinality. Now let's go to the system and have a look at the action, its class, and how you can set it up as being relevant for create, change, or delete mode. Okay, so let's look at the BOPF UI and look at the business object TRQ. So we look into the forwarding order and see if we can find an action there. Double click, not the node structure, node elements. And let's look at the stages, for example. And here we have lots of elements, so let's look at the actions. And here we have action remove stage, save stage, split stage, and validate stage. So the remove stage, this action is probably removing the stages. You have the name of the action, the node that it relates to, the stage node. This action category is option specific. It only makes sense on a stage to remove the stage. Doesn't make sense on an item. Then you have multiple node instances as cardinality. You could have static or single node instances as well. Then you have here the change mode, only read mode, or exclusive write mode. In this case, we are removing stages, so we need the write mode. And this is a standard action, and here you can see a flag that it can be enhanced. Then you can see the class that's actually doing the deletion and the different methods: execute, prepare, retrieve. And in the execute methods, you have the importing parameters, is_ctx, for example, and their associated types. And you also have the exporting parameters like message or failed key. So this is it so far. Maybe we can look at the parameter sets. I wanted to tell you about read and write. So normally you do this in this tab. You can say whether it's a create, update. This action should be called at create mode, creation mode, update mode, deletion mode, or it's modeled only. In this case, it doesn't have a flag like this, but we will see flags like that in the determinations, which will be our next subject. Okay, next subject, determinations. So, as we said initially, we have a clear separation between an action, what we saw just now, just doing something, adding a container, deleting a stage, and a determination, which is actually something that is using two fields, for example, in an object, and calculates the total price. You can see this as an example here. For example, when you take the item quantity, you multiply it by the price, and then you get the total price. This would be typically something that could be coded in a determination. A determination is, so you can see it here in the SAP screen, it's also assigned to the object. It has a name, determination category, persistent or transient. And then you have write or read mode as well, and you also have a class or an interface that allows you to assign coding to the determination. A determination is mostly used to compute data that can be derived from the values of other attributes. This is the example with the item quantity, the price, and the total price. There are persistent and transient determinations. So now it's interesting what data we need at runtime and what data we need forever. So persistent are changes that are written away, saved, kept forever. So we have here friends forever, it's persistent. And transient means data are only used temporarily, are only used at runtime. These two concepts are important in the object-oriented world, and we will see them again many times. So persistent is forever, for longer, and transient means only temporarily at a long time. at runtime. And here transient means only guest, the data is only there as a guest doing the program itself, and then it can be forgotten. A determination must indicate for each determination if it's a create, update, or delete, or load determination. So this is about the timing. We saw that just now in the system for the action. Yeah, we are going to look at this for the determination as well. In addition, the determination is called at different points in time depending on a model, and this module is described on the next slide. So let's look at the execution times for determinations. So for those who know user exits may know some of those. In the old world, the user exits were different. Save document prepare, for example, was user exit that was called after the user had entered all the data and before saving, so that you could do some calculations before saving. And then you had other user exits, for example, for doing the number range. So these execution times for determinations are similar to this concept, and but you don't have separate user exits, which means you don't have to. Sometimes in the old world, you had to repeat the same coding in different user exits to make sure that they would be executed at different times. Now, this object-oriented world, it allows you to keep the same coding at one place and just click if you need it at different times. So let's look at the times that we have possible. What is after loading? Dependent fields that are not saved, redundant fields, have to be recalculated. So then you have before retrieve determining contents of transient nodes before their first retrieval. After the first retrieval of a node instance, determinations for this determination time are not executed, as change to data during retrieval are not allowed. Then we have after modify. So this is similar to the save document prepare and is used a lot. Recalculation of fields that depend on changed fields. So it depends, some user has changed a field, and if that field was changed, you need to execute the coding, because some of your calculation depend on that field. This is especially useful for derived fields that are of interest to the outside world and need to be updated immediately. Then you have after validation. So this point in time can be used to modify data based on the outcome of consistency validations in the determination and validation cycle. So for example, follow-up actions if errors have happened. So you validate, for example, a field, your own custom-made field. The user has entered a wrong entry or something that doesn't match with the rest of the fields. You want to handle this as an error, and you want to do a follow-up action to that error. Then you have another user exit or execution time for determination. It's before save, finalize. Determine data that must not be determined prior to saving or for data not visible to the outside world, can be determined for performance reasons after saving. So now if that field, what you're calculating, does not need to be seen by the users as a result, then you can use this one. Actually, this is more close to the save document. This is save document at saving. And then you have a special time as well for the number ranges. So this is called draw numbers in the object-oriented world or in the BOPF world. So changes that must happen only if the transaction was successful. Of course, the order must have been totally successful before a number must be given. Otherwise, you might have a number that is thrown away right afterwards. So that's a special timing. And the example is, of course, to give out a number for the document and make sure that the number are in a correct sequence and no number is missing. Then you have during save for changes that must happen only if the transaction was successful, but no need to be visible. So again here, only if the order was successful, this time is executed. this timing will be relevant, but the result of your calculation does not need to be visible to the user. Then after commit, determine data after a successful transaction, for example, asynchronous process. And when I hear asynchronous process, I often think of analytics, updating of BW or analytic relevant data, which can be done after the transaction, doesn't need to be done during save, can be done when the user is out of the order and doesn't need to wait for it. Then you have after failed save attempt. So in this case, you can do cleanups after the user has tried to save a transaction and was rejected during the finalization or before saving the stages. And the determination is only triggered if request nodes are assigned to it and instances of these request nodes are changed. So this is it. And after all the theory, let's look into the system, see if we find the determination in the forwarding order item, and if we can see what execution times they are using. Let's also look into a sample determination class used in the standard determination. Det underscore item underscore AM has a method that determines the item category after checking if some fields are filled or empty. Okay, now let's look into sample determinations, and we wanted to see a determination in the TRQ object in the forwarding order on the item level, and we wanted to look how the item category is determined. So first of all, we see here again a determination name and a description. This is happening after modify. We will see where this is indicated. Then we have the node that it's related to the item, the category, persistent or transient. In this case, it's persistent. We keep the data for a long time. And we have write mode. And here we have the class interface where the coding of the determination can be found. Now let's have a look at the nodes. So here the request nodes are important. So we can see the determination of the item category will be done at create, update and deletion mode, not at loading and not at determine. Now, I'm just going to look at the category assignment. Exactly, this is what I wanted to show you. So here we can find the times that we just saw, and we just have to click for after modify. If we need the same coding again before save, we can click it here again. Now let's look at the class that's defaulting the item category to get an example. So this is the class that was assigned to the determination, and it has many methods. We look at one method that wants to determine the item category. So determine item category, here it is. So when we look at we click on the method, we can see the parameters. So as importing parameters, we have the item category of the item where we are. Then we have as changing parameters the items that are changed with all the fields and the types here. So let's look at the coding now of the method. So basically we are checking in the coding if the TU, as a transport unit resource data, is filled. So if the resource data is not initial, then the item category is this. So what is this? TRQ item category TU resource. So this is referring to the constants interface, and we can double click here, go to the attributes, go to the TRQ category, TRQ item category, and then look at the constants, and we can see TU resource means TUR. So in this case, the system is going to set the item category to TUR. Okay, after this system demo of the determination, let's go to the next element, validations. So as you can see on the picture, validations are used to check things, to check if everything is okay. They are also assigned to an object. In this case, it's the TRQ object, the forwarding order. They have a name. They are related to a node, for example, forwarding order item. They can be persistent or transient. Persistent where the data is kept, or transient where the data is used only at runtime. Then we can have a change mode, write or read mode, and then in the class interface you can find the coding. A validation is an element that has some internal checking business logic on the business object. Okay, it can be used to check if an action is allowed, and then it's called an action validation. And it can be checked if a business object is consistent. In this case, it's called a consistency validation. The trigger can be at action call, for example, or it can be based on a trigger node. If it's based on a trigger node, it means that a change of an attribute of that node will trigger the action or will trigger the validation. So that's it for the theory about validations. We will also have a look at the system. Okay, let's look at the validation now of a forwarding order item. So again, we go into the forwarding order, we look at the node elements, we go to the item, we look for validation, and I will take the completeness check. So we can see here validation name, it's related to an item, category is a consistency check, and then we have the class interface. So we can look here when this is happening. So this is happening at check. It's a check. Okay. And no read nodes. No dependency. We could have preceding and succeeding validations as well. So let's look at the coding. So here again we have the class and the different methods of the class. So let's look at the amount consistency, look at the parameters. So we have a message as changing parameters, and as importing parameters we have the value and the currency, and also a message type. So let's look at the coding. Okay, so we are checking first whether amount is filled, and we have two possibilities. Amount is filled but no currency, so amount value is not initial but the currency is initial, or the currency is not initial and the amount is initial. Okay, if the amount is initial but the currency is filled, then we throw out this message here, message class SCMTRQ044, number 044. So currency is missing, and 45 would be amount is missing. So we are saying here, if the amount is initial, then throw out message 44, and if the if the currency is initial, throw out message 44, right? Currency is missing, yes. And if the amount is initial, or else, if the currency is not initial, then the amount is initial, then we throw out message 45, which is amount is missing. And after that we have to use, call a method, a helper class, which is adding this message into the framework. And so basically at the end we just have to call this message and enter the data related to it. And then we have other checks. Here, for example, we have negative amount values as well. We can check. So if the amount is lower than 0, then we have that message 102. Okay, what is 102? Probably amount is negative and should be positive. Negative amount not allowed. Exactly. So this is the idea of validations, but of course the interesting thing is to use this framework, because then the validation can be used wherever it's necessary. Okay, that's it for the validation business system demo. Okay, so you can see, last but not least, we will look at queries. So queries represent a defined set of attributes, such as search parameters that return the queried IDs of the business object node instance. You can see on the screen there's a guy searching for something. So a query is a search, a predefined search on a business object. The query is assigned to the item here, for example, to the forwarding order item. You have a query name, the node is specified, query category, and you have a query class here where the coding of the query is. You have an input data type, which is a structure, and you can have result types, which can be structures or tables. So, sum it up, a query allows you to perform searches on a business object and provide the point of access. The search parameters are predefined, and the result is a set of all record IDs that match the criteria and can also be predefined. So this is the end of part 1 of my films about the BOPF framework. So in film 1 we have talked about architecture, business object model and BOPF modeling tool, and we looked at everything at a high level. In my second film we will talk about the consumer implementation basics, the service manager, and how you can actually read the data, retrieve data from business objects, and from several business objects do actions in business objects. In film 3, Enhancement Workbench, you will actually see how to create field extensions, subnodes, actions, and so on. Thank you very much for your attention. I hope it helped you to understand BOPF, and see you soon. Bye-bye.